Welcome to Unit 9-2. We're going to be looking continuously throughout this unit on systems of equations. In today's work, we're going to be looking at solving by substitution. First, our math career, and this is an operations research analyst. You can see, of course, the salary up there. Pretty moderate at the beginning and gets healthier as they go along. Basically, in a nutshell, these creative people move stuff around. They strategize, plan, and forecast when things are going to be needed. They use advanced techniques from mathematics, science, and engineering to make better decisions and solve problems. And at the bottom, the last sentence there, they've also been used in wartime to effectively deploy radar, search for any submarines, and get supplies to where they're most needed. So quite a interesting career here with lots of applications in both business and government and military. And nonetheless, you can see your mathematics here, and you're right at the gateway of this possibly being something you might want to look at. Operations Research Analyst. Okay, today we will learn to solve a system of equations by substitution. Our vocabulary here: systems of linear equations and a solution of a system. And remember that a solution of a system is always going to be this x comma y, ordered pair, alphabetical order. Yes? Okay. Alright, so systems of linear equations are two or more linear equations containing the same variables, in this case x and y. So here is one linear equation and here's another. And our job here is to find possibly an x and a y that satisfies both of these equations simultaneously. Alright, so sometimes it's difficult to identify the solution to a system of equations by graphing because it may be difficult to see all the details. So, what can we do? An additional way to solve a system is by substitution, which we may have been practicing recently. Alright, to solve a system of equations problem by substitution, let's do this. So here's a system. You've got y equals 3x and y equals x minus 2. Looks to me like we have a value here for y. So step one, what's in red here you might want to add to your notes. This is why you got this little note thing up here. Isolate one variable, either the first or second equation. Notice in this one, y is isolated, yes? Y equals 3x. So this is telling you that wherever you see the letter y, we can plug something in for it. We can exchange it. It's the same thing as having, let's say, a dollar bill in one hand and 4 quarters in the other. You can switch hands and you have the same amount. It's just two different images of the same value. So in the first equation here, y is already isolated. Okay. Now, step two, substitute the isolated variable into the other equation so that you're only solving for one variable. That's the key here. We know we have two equations and two variables. We'd really like to have solve one equation at a time, but only using one variable. So let's take this y equals 3x, and do you see this y here? We can replace this letter y with its exact value, which happens to be, in this case, 3x. So you'll see that I can just erase the y and replace it with 3x. Now we've got a nice problem we've seen for quite a while: variables on both sides, and solve for x. So step 3, of course, is to solve for the isolated variable. Get rid of the smaller version of x. And you're looking at 2x equals negative 2. Divide both sides by 2. And so, of course, x is negative 1. Now, that is one of the pieces to our puzzle here. So now what do we do with this negative 1? Now, step 4. Substitute the known variable into one of the original equations. So remember, we can substitute into either equation. And then we'll be able to solve for, in this case, y. So plug a negative 1 in there. You see x equals this. Plug x, this value here is going to be negative 1, and just simplify. And there you got y is negative 3. So we know what x is, we know what y is, and now you've found an ordered pair that satisfies the system and solves the system simultaneously. So step 5, write your answer as an ordered pair. Negative 1, negative 3. Good. Alright, now of course if we wanted to take these and check the answers, these were our two original equations. Plug them in and just make sure that they're true. Is it true that negative 3 equals negative 3? Yes. And is it true that negative 3 is the same as negative 1 minus 2? Of course it's true. And so there, we've got our ordered pair. So let's practice together here. So write this one down. Y equals x plus 1 and 4x plus y equals 6. All right. They're a little bit messier here because you do have x plus 1. This is a binomial now, but we do have y isolated. So again, we've already isolated y. Take that value here, and do you see a y in the second equation? So let's go ahead, this y equals this, so this y should equal the same thing, correct? So we're going to replace or substitute the isolated variable into the second equation. So this thing will go right there for this y right here. So here, 4x plus, instead of y, I'm going to plug in x plus 1 equals 6. And now notice I've gone from having two different variables just to one variable. Combine like terms and solve for x. Solve for the isolated variable. So we're looking at 5x plus 1 equals 6. That's simply 4x plus 1x plus 1. Do a little bit of solving here from 6th and 7th grade. And we end up with 5x equaling 5, so x equals 1. Now what do you do with that 1? Well, with this 1, we're going to plug it into either equation we want to. So step 4 now, substitute this in. And I'm just going to choose this guy here. Looks the easiest. So 1 plus 1, of course, is 2. So what's our order pair then? Order pair is 1, 2. And you can take the 1, 2, the 1 for x, and the 2 for y, plug it into the original equations, and it'll turn out to be true for both equations at the same time. Alright, so how about you try this one on your own here. So you got your notebook, you're ready to go, and there's your system. Y equals x minus 2, and 2x equals y plus 4. Alright, go ahead and press pause, get that started, and I'll be here when you get back. Let's see how you did here. We're going to take the y, and I'm going to plug in. What am I going to plug in here for y? I'm going to plug in this x minus 2 right here, and then I'm going to solve for x. So I'm going to plug that in. And now I've got x's on both sides. I can combine these like terms here to get positive 2. Get rid of the smaller version of x. And just like that, we've got our answer. X is going to equal 2. What do I do with x equals 2? Plug it in right here. I just used the top equation. What's 2 minus 2? 0. Just like that, you've got your ordered pair, 2, 0. Okay, that's it for 9-2. If you'd like more instruction, Dr. Berger and his company will be glad to help you out here. Just go to this website, plug in this code, watch example 1 and 2, and right at that same place there is digital practice for you. You can hit the digital practice there and get some immediate feedback. All right, we'll talk to you soon.